In this lesson, we're going to introduce radicals, and the scope of this lesson is defining radicals, simplifying radicals of degree 2, and simplifying radicals of degree 3, as well as developing or generating a general rule for simplifying radicals of any degree. So a radical is an expression that is bound by the root sign. So now let's look at this example here. This is an example of a radical. So it consists of three parts. X, which is the number under the root sign, is called the radicand. 3 is the degree of the radical, and you have the radical symbol. Now look at these examples here. What is the degree of each of these radicals? Now, mathematically, whenever we don't have a number enclosed in this radical sign, we assume that it's going to be, we safely assume this is the same as this, 2x plus 1. So the degree here is 2, and here we have a 5 here, so the degree is 5. Now we're going to simplify radicals. We start with degree 2. The first thing we're going to do is we're going to decompose the radicand to the product of its prime factors. So this is factor trees. We have a lecture that focuses on that. So 36, we have 2 and 18. You must use prime factors here. We have 2 and 9, and then we have 3 and 3. So 36 is the same as 2 times 2, and then times 3 times 3. So now we're going to group similar factors in pairs. So this is one pair here, and this is another pair. Select a number from each pair to represent the pair. So square root of 36 is now, we're going to select from here 2, and then we select from here 3. We multiply them together, and 6. So square root of 36 is 6. Now let's look at this and apply the same rules. 24, let's decompose 24, 2 and 12, 2 and 6, 2 and 3. So now let's rewrite this. 24 is 2 times 2 times 2 times 3. So let's group, we just have this pair of 2. So 24, square root of 24 is 2, and then we have 2 and 3. So this right here comes from a representative pair. This doesn't, so we're going to put a radical sign around it. So this is going to be 2 square root of 6. Another example, 98. Let's decompose it to 49, 7, 7. So 98 is 2 times 7 times 7. This is a pair right here. So square root of 98 is 2 times 7. 2 is not part of a pair, so we'll put a square root sign there. So the way we write it is we would like to use the integer or the number that is the free number on the left hand side of the radical. So 98 is 7 square root of 2. Let's look at one more on degree 2. So 125, let's decompose that. 5, 25, 5, and 5. So 125 is 5 times 5 times 5. So we group in pairs. So square root of 125 is 5, which is part of the group, and then this 5 is alone, so we just put the square root sign. We put it under the square root sign. So this is 5 square root of 5. Now let's look at degree 3. We're going to follow the same method. The only difference here is we're only going to be interested in grouping by threes, and any number that does not have a group of 3 is going to be under the radical sign with a degree 3. So 27, we have 3 and 9, we have 3 and 3. So 27 is 3 times 3 times 3. So we have a group of 3, so we're going to bring that out here. So the cube root of 27 is going to be equal to 3. Let's look at the cube root of 32. So 32, let's decompose that. 2 and 16, 2 and 8, 2 and 4, 2 and 2. So 32 is 2 times 2 times 2 times 2 times 2. So now when we want to find the cube root of 32, we're going to just pick groups of 3. And so we have 2, and then we're going to put 2 times 2 here. So we now have 2 cube root of 4 as the solution to this. Let's try for 81. 81, let's decompose that. We have 3, 27, 3, 9, 3, 3. So 81 is 3 times 3 times 3 times 3. So cube root of 81, we're going to create groups of 3, and then we put the ones that don't have any group under the cube root sign. What about any degree? When you're dealing with any degree, it's the same method. The only difference is that you create groups based on the degree of the radical that you're dealing with. So look at 16 here, 2, 8, 2, 4, and then 2, 2. So 16 is 2 times 2 times 2 times 2. So the fourth root of 16 means that we have to create groups of 4, which is just 2. And final example here, 162. We have 281, 327, 3, 9, and then 3, 3. So 162 is 2 times 3 times 3 times 3 times 3. And so the fourth root of 162, you can see there's a group of 4 here. So it's going to be fourth root of 2 times 3. And just standard practice or standard convention when dealing with radicals is the free number is always on the left hand side of the radical. So this method that we've kind of walked through here will apply for any radical regardless of the root. If you just remember that the number of similar numbers in a group is determined by the root that you're looking for. So if we were looking for something for the fifth root, we will also decompose and then we'll group similar numbers in groups of 5. And anything that does not fit into a group of 5 will be considered under the radical sign as well with the root.